B10, which covers the bond energy and enthalpy changes. Alright, solution B10 gives us the equation: hydrogen gas plus fluorine gas produces 2 hydrogen fluoride gas. Part A asks us to construct an equation using structure formula showing the bonds. This means instead of writing H2 plus 4 plus F2 arrow equals to 2 HF, we draw each molecule showing the single bond between the two atoms. So H, you have the bond with another H, plus F with another bond F, will give us two separate F with separate H with F molecules, each showing a single bond between the hydrogen and the fluorine atoms. Part B refers to the bond energy table, which gives us H connected to H bond plus 436 kilojoules per mole of F to F bond, as plus 138 kilojoules per mole, and H to F bond as plus 562 kilojoules per mole. Then part BI asks us to calculate the enthalpy change, which is delta H for the reaction. So let's walk through this step by step. Have your pen and paper. Please, if you haven't subscribed, please subscribe. If you haven't liked, please like. And please, if you have any question why you feel you are stuck in this past paper video, please comment so that I can help you or give you exactly same number. Make sure to state the question number and the exact part of the question, then state why you're not understanding. Don't just don't just come out and comment the exact problem. No, I don't understand why the answer is coming from. How can you comment like that? How will I know that you're watching this question number, this or question number one? So please make sure you read the question number and the part of the question, so that at least when I'm responding to you where you have the question, I can know exactly where to go. Thank you. Now let's continue with our calculation. Alright, so step number 1, calculate the energy needed to break the bonds in the reactants. We break one H to H bond and one F to F bond. That's 436 plus 138, which gives us 594 kilojoules per mole absorbed. Step number 2, we need to calculate the energy released when the bonds in the product are formed. We form two H to F bonds, so that's 2 times 562, which gives us 1124 kilojoules per mole released. Step number 3, calculate the delta H using the formula energy absorbed minus energy released. That's the 594 minus 1124, which gives us minus 530 kilojoules per mole. Since the answer is negative, this tells us the reaction is what? Exothermic. Please, if you haven't watched a video on how to draw these energy profile diagrams, please do comment in the comment section so that I can send you the link of a video on how to draw these diagrams. Or you can watch this video where I will teach you how to draw it as well. Okay, meaning it releases what? Energy overall. Okay, moving on to question B2. So question B2 asks us to draw an energy profile diagram for the reaction, labeling the reactants and products, delta H and the activation energy as EA. Here's how to picture this diagram. So on the vertical axis, we have the energy, and on the horizontal axis, we have the progress of the reaction. Since reaction is exothermic, the reactions start at a higher energy level, or in other words, the reactants will be what? On top. And on the left side of the graph, the curve then rises up to a peak, which represents the activation energy. That curve simply represents what? Activation energy. And before dropping down to a lower energy level on the right side where the product sits. So when you're doing the diagram, the energy profile diagram for the exothermic reaction, just know that the reactants are always on top, then the product are always at the bottom. Or in other ways, I like calling it as a normal one, because we know that the product should always be at the end. So which means the opposite is true for the endothermic. The products will be on top, the reactants will be at the bottom. I've learned one or two things there. If you have learned something, please comment and let other people know what you have learned in the video. Alright, so moving on to the question. The activation energy, which is EA, is labeled as the vertical distance from the reactance up to the peak of the curve. Delta H is labeled as the vertical distance between the reactance energy level and the product's energy level. In short, the distance between those two, that's where the delta H is what is placed. Alright, moving on to question C, which is access to definitions. But C1 asks what is meant by the activation energy. So activation energy is simply the minimum amount of energy that colliding particles need in order to react successfully. So activation energy is the minimum amount of energy that colliding particles need in order to react successfully. Then part C2 asks what is meant by the term bond energy. What is meant by bond energy? So bond energy is the amount of energy required to break one more of a particular covalent bond in the gaseous state. Moving on to part D. D tells us the reaction is then catalyzed and asks us to show EA2 for the catalyzed reaction on our diagram. When a catalyst is added or is used, it provides an alternative pathway with a lower activation energy. So on the same diagram, you would draw a second curve with a lower peak than the original one, meaning that just beneath it, you draw the label. Label this lower peak as EA2, showing that less energy is needed to start the reaction when a catalyst is present. And that's question B10 complete. 10 marks. Now let's move on to question B.